Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is detection in high ceiling spaces. Let's give it an introduction. Fire detection in high ceiling buildings is more challenging than in standard spaces and requires careful design. As the ceiling height increases, smoke, heat, and flames take longer to reach the detector, which can delay detection if the wrong type of detector is used. In these spaces, smoke tends to spread out and lose density. It also takes more time to rise to ceiling level, and in some cases, hot air and smoke can remain at intermediate heights due to stratification. In addition, air movement of HVAC systems, natural ventilation, or door openings can affect the direction and distribution of smoke. For these reasons, standard detector placement is often not sufficient in high ceiling environments. So let's look at a comparison table that shows which types of fire detectors can be used depending on the room or ceiling height, in line with EN 54 standards. For high ceiling spaces, point smoke detectors are generally not suitable for heights above 12 meters. Linear smoke detectors, in other words beam detectors, can be used in spaces with ceiling heights of up to 16 meters. Aspirating smoke detection systems, when the correct class is selected, can be applied in these areas with ceiling heights of up to 45 meters. Flame detectors remain effective even in very large and high-volume spaces. Heat detectors, on the other hand, are usually only suitable for low ceilings or for special applications. So, beam smoke detector. Under normal conditions, the beam transmitted from the transmitter reaches the receiver without any loss. In the event of a fire, smoke in the protected area reduces the intensity of the beam before it reaches the receiver. If this reduction reaches or exceeds the alarm threshold set by the user and continues for 6 to 8 seconds, the detector generates an alarm signal. The characteristics and performance requirements of beam-type smoke detectors are defined in the EN 54 to 12 standard. Smoke detectors used in buildings must have an EN 54-12 CPR certificate issued by internationally accredited certification bodies. Beam smoke detectors are available in two main types: transmitter-receiver type and reflector type. Transmitter-receiver beam smoke detectors consist of two separate units, a transmitter and a receiver, which are installed facing each other, and the distance between these two units typically ranges from 5 to 100 meters. Under normal conditions, the infrared beam emitted by the transmitter is received continuously by the receiver. During a fire, smoke obstructs the beam, allowing the detector to identify the presence of fire. The second type is the reflector beam smoke detector. Let's move on. Here is the receiver and transmitter. Here is the light beam. So let's continue. In high ceiling spaces, smoke becomes less dense as it rises during the early stages of a fire and often forms a layer below the ceiling. Because of this, ceiling-mounted optical or point smoke detectors may detect smoke very late or sometimes not at all. Since point smoke detectors only sense smoke at their exact location, a large number of detectors is needed in high-volume areas, which also makes installation and maintenance more difficult. Beam smoke detectors work differently. They are usually installed about 5 to 10% below the ceiling, on columns or facing surfaces, and continuously monitor a wide path of air. This allows them to detect smoke as soon as it reaches the beam line, before it has time to spread out and lose density. As a result, beam smoke detectors offer earlier detection, higher reliability, and more cost-effective solution in high-ceiling environments such as warehouses, factories, and hangars. For this type of spaces, beam smoke detectors are clearly more advantageous than optical smoke detectors. There are two types of beam smoke detectors: transceiver unit and reflector type. Beam smoke detectors with transceiver units consist of two main elements, a receiver and a transmitter. The receiver and transmitter are mounted opposite of each other, and the distance between the two units should be between 5 and 100 meters. Under normal conditions, the IR infrared beams emitted from the transmitter fall on the receiver. However, in case of fire, the smoke prevents the exchange of beams. The detector detects the presence of a fire in this way. The other type of beam smoke detector is the reflector type. Reflector beam smoke detectors consist of transceiver unit and a reflector. The transceiver unit and the reflector are mounted opposite of each other, the same as the transmitter and receiver unit. If 4 reflectors are used, a distance of up to 50 meters can be left between the transceiver unit and the reflector, as you can see. Then as you can see in the image, the placement of a single reflector beam detector is like this. If a single reflector is used, a distance of up to 35 meters can be left between the detector and reflector. So, in buildings with high ceilings, all fire protection systems need to work together properly. Alarms, detection, smoke control, sprinklers, everything. These guidelines are just a starting point, and sometimes extra detectors or special layouts are needed. In large high spaces, you usually don't need to monitor every level, but linear beam smoke detectors are recommended. They should be installed around 9 to 12 meters high. If detectors aren't within the top 10% ceiling zone, the spacing between them shouldn't exceed 25% of their mounting height. And if smoke stratification is a concern, adding angled beam detectors can help improve detection. The detector detects objects from its right and left sides in a range of 6.2 plus 6.2 meters. When both the receiver and transmitter units are used, the detection range is 100 meters. It is mounted so that it remains below 10% of the ceiling. When beam detectors are installed outside the top 10% of the ceiling area, where smoke normally collects during a fire, their detection performance can decrease. This is mainly because smoke spreads horizontally and becomes more diluted at lower levels. To reduce this effect, the horizontal distance between beam detectors need to be kept shorter. For this reason, If beam detectors are installed outside the 10% of smoke accumulation zone, the maximum horizontal distance between two detectors should not exceed 25% of the height at which they are mounted. For example, in a space with a total ceiling height of 20 meters, if the beam detectors are installed at a height of 10 meters, this level is below the 10% zone. In this case, the maximum horizontal distance between the beam detectors should be limited to 10 meters multiplied by 0.25 equals 2.5 meters. This arrangement improves detection reliability by increasing the chance that at least one beam will be interrupted as smoke moves horizontally. So in summary, beam smoke detectors are considered the most suitable option for high ceiling spaces according to the standard. Smoke particles partially reduce the beam intensity, which allows the detector to identify a fire condition. However, when a solid object enters the beam path between the transmitter and the receiver, the beam is almost completely blocked, usually by 90 to 100%. If this kind of obstruction is brief but continues beyond a present delay time, typically 6 to 8 seconds, the detector should move into a fault state. If this situation is instead interpreted as a fire condition, it may result in a false alarm. For this reason, this operating behavior should be taken into account when selecting and setting up a beam smoke detector, especially in environments where temporary obstructions may occur. Thank you for your listening. Next week we will be talking about the relationship between access control systems and fire detection systems. See you next Thursday at 11 a.m.